Hello students, welcome to Senior College Mathematics. Topic of discussion is matrices and determinants. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NACTEP, for JAM, or any other external exams into high school, this lesson is for you. You are in the right place. Petakus education community. Lesson 6, powers and polynomial of matrices. Powers and polynomial of matrices. Before the lesson proper for updates, follow Petakus Educom via YouTube at Petakus Simplified Maths. To do that, subscribe to the channel, hit this button, you are there. Share, like this video, share it to your friends, your classmates, your colleagues. You can follow us on Facebook at fb.me/Petakus Instagram at Petakus EC, Telegram t.me/Petakus WhatsApp through this mobile telephone number. In all of these platforms, you get updated from time to time about what is happening at Petakus education community, where you have access to quality, unlimited, and simplified mathematics teachings. Okay, so it's two concepts. So let's do the first one: powers of matrices. If P is an n square matrix, in other words, P is a square matrix, powers of P are defined as follows. Possibly means when the matrix is raised to any integer. So P power 1, any base number power 1 remain the same. So P power 2, that is P squared. That simply means multiply matrix P by itself. P cube is triple multiplication, or you can also use P squared times P. Then P power 0 is 1 because of the fact that any base number power 0 is 1. Then P power n plus 1. From the law of indices, you can also express this one as P power n times P power 1, also written as P power n times P. So this is how we compute powers of matrices. Let's go straight to examples. Suppose P is equal to this matrix. It's a 2 by 2 matrix. The first row is 1, 5, second row 0, 6. You should find P square, P cube, and P power 0. What we do in power most of the time is multiplication, except the power is 0, except so. Okay, this is matrix P. You are asked to look for P square, which is the same thing as matrix P times matrix P in this form. If you have followed, let's see, 4 and 5, I'm very sure by now you have no problem in multiplication. If there is any, you can contact the voice of Petakus through the comment section. Ask your question. So the dimension are already the same, so number of columns and row are the same. So you have the first row times the first column, that gives you 1. The same first row times second column times second column, you have 35. That is 1 times 5 is 5. 5 times 6 30. When you add, you have 35. second row times first column, you have 0. The same second row times second column, you have 36. That is 0 times 5, 0. 6 times 6, 36. When you add, you have 36. So you know p square. So let's get p cube. Since square is contained in cube, instead of using p times p times p, let's write p cube as p square times p, where this is matrix p square times matrix p. You use the first row of p square to multiply first column of p. That gives you 1. The first row of p square times the second column of p, that is 125. If you check that out, the second row of p square times first column of p, that is 0. Second row of p square times second column of p, that is 216. So that is a matrix p cube, power of a matrix. Of course, p power 0 is matrix p to the power of 0, and that is 1. That is 1. Okay? Then let's look at polynomial of matrices. A polynomial is a function with the general form f of s. You can denote a function as f of s, and that function can be written as a plus bs plus c squared plus ds cubed, and so on. Now, polynomial is the general name for all equations. For instance, polynomial of degree 1, they are called linear equation. That is a plus bs, a linear equation. Polynomial of degree 2, they are referred to as quadratic equation. You take it to cs cubed now, cs squared. When the power is 2, you have quadratic equation. Polynomial of degree 3, they are called trinomial or cubic equation. So you have ds cubed. So polynomial of degree 1, 2, 3, they have special name. But as from degree 4, there is no special name for it. So refer to them all as polynomial. Okay? Where a, b, c, d are scalars, that is, they are constant, then you are, so we are to look for f of a, where a is a matrix. From the given polynomial, you can find f of a, that is, when matrix a is substituted into the function in place of s precisely. So if you do that, we have the matrix is defined as, so f of a now. See that? So you replace a, replace s with a, you have ba, then ca square da cube. As you are doing that, the term without s, that is a, attract identity matrix, that is matrix I. You know, I told us in lesson 1 that identity matrix is a diagonal matrix that is a square matrix, such that all the diagonal elements are unitary, that is 1. So as the matrix replace the variable, replace the variable or the letter s, the constant without s attract the identity matrix of the same size as matrix A. Okay, so f of a is obtained from f of s by substituting the matrix A for variable S and substitute the scalar matrix AI for A, since A has no variable. Okay, that is, as A is replacing S, the scalar, that is the constant without SA, attracts the identity matrix of the same size or order or dimension with the given matrix. Are you following? Yes, sir. All right. Example 17. Given that f of s is equal to 2s plus 4, so this is polynomial of degree 1 linear function. Find f of a where a is equal to this matrix. So this is f of s now, but you are asked to find f of a. If you check this position of s and a to get f of a, it simply means replace s by a in the polynomial. So you have 2a, but 4 is a constant without s. As you replace s with a, you now attach identity matrix of order 2 to constant 4, because matrix A is a 2 by 2 matrix. So you have 4 times identity matrix. All right, this is matrix A now. Then you have to look for 2a. So 2a is 2 times matrix A. So this is scalar multiplication. When you have 2 times 1, 2, 2 times 5, 10, 2 times 0, 0, 2 times 6, 12. That is this matrix. Then you look for 4i. So you can see now matrix I here. Matrix I is identity matrix. 1, 0, 0, 1 is a 2 by 2 matrix because matrix A is 2 by 2. So if 4 multiply 1, 0, 0, 1, you have 4, 0, 0, 4. Now can I look for 2a? So f of a. So f of a is 2a plus 4i. So this is 2a. You add it to 4i. And you know when adding, the dimension must be the same. So 2 by 2, you add corresponding element to corresponding element. So you have 2 plus 4, that is 6. The 6 you have here. Then 10 plus 0, you have 10. So I'm doing now element to element. Then if you add 0 plus 0 is 0. Then 12 plus 4 is 16. So this is how we do polynomial of a matrix. All right. Example 18. Suppose f of s is equal to 3s cubed minus s plus 1. 3s cubed minus s plus 1. Find f of p if matrix P is this. Matrix P is a 3 by 3 matrix. So you go, this is the polynomial. You replace s by p to get f of p. So in place of s, you put p, you have 3p cubed, then minus p. If you multiply 1 by I, you have I. That is identity matrix. So this is matrix P. Then matrix P cube is P squared times P. Now matrix P squared is P times P. So I've done that, and this is the solution for matrix P squared. Matrix P squared. You can do that because you've learned multiplication of matrices in the previous two lessons. Then multiply by matrix P. This is the result. Okay, we are still there. Okay, we are trying to get P square first. So P square now is matrix P. This matrix P now. This matrix P times matrix P. No, I didn't jump that. Matrix P times matrix P give P square. So you can see the step now, 3 by 3. You take the first row to multiply first column, multiply second column, multiply second column. That gives you everything you have here, everything you have in this place. Then you take the second row to multiply first column, second column, third column. You have everything here, and you use the third row to multiply first column, second column, third column. You have the last one. So you multiply and you add at each step. When you do that, you have this matrix for P square. You have the matrix for P square. Okay, matrix for P square. It's like I'm going to explain it, so let me do that. Okay, all right, I said I'm going to explain it. So the first row times first column, you have this result here. See that? Then the same first row times second column, you have this result. Element by element, that is 2 times 1, 1 times minus 1, then 2 times 1. The same first row times third column now. So you have this, where you have 2 times 2. Okay, let me show that. So this 2 now times this 2, you have 2 times 2. This first one, second one is 1 times minus 2. You have this, and you have 2 times 2 times 5, 2 times 5. So you have 2 times 5. Okay, you move to the second row of P, that is 3 minus 1 minus 2. So this is the second row now. Second row times first column, 3, 2 minus 2. When you do that, you have this 3 times 2 minus 1 times 3 minus 2 times minus 2. The same second row times second column, you have everything here. 3 times 1 minus 1 times minus 1 minus 2 times 1. The same second row times third column, you have this. Okay, now you take the third row times all the columns one by one. So third row times first column, where you have minus 2 times 2, 1 times 3 minus, okay, 5 times minus 2, 5 times minus 2. The same third row times second column, you have this. Third row times third column, you have this. You have this. Okay, so you multiply the first entry, the first row, 2 times 2, you have 4. 1 times 3, you have 3. Plus times minus is minus. 2 times 2 is 4. The second entry, so here I am now. So 2 times 1 is 2. Plus times minus is minus. Then 1 times 1 is 1. Then 2 times 1 is 2. So the third entry, you have 4 minus 2 plus 10 when you multiply. The second row, you have 6 minus 3 plus 4. You have 3 plus 1 minus 2. The third element, the second row now, you have 6 plus 2 minus 10. Then the third row, the first entry is minus 4 plus 3 minus 10. That is here, minus 2 times 2 minus 4. 1 times 3 is plus 3. Minus 5 times plus 2 is minus 10. Then for the second entry in the third row, you have minus 2 minus, okay, minus 2 minus 1 plus 5. That is minus 2 times 1 minus 2 plus 1 times minus 1, you have minus 1. 5 times 1, you have 5. And the last entry in the third row, minus 2 times minus 2, you have minus 4. 1 times minus 2 is minus 2, and 5 times 5 is 25. So when you add the entry in all the positions, you have this resulting matrix. So this is P squared. Then let's look for P cubed. Okay, so P cubed now is P squared times P. So this is matrix P squared, and this is matrix P. So the way we obtain P squared, that is P times P, the same way you will obtain P cubed times P. You obtain P squared times P, that is P squared times P, and this is the resulting matrix. You now look for 3P cubed. This matrix is P cubed. Then you look for 3P cubed, where you multiply matrix P cubed by 3. That is scalar multiplication. 3 multiply each of the entries. For the first row, 3 times minus 9 minus 27. 3 times 12, 36. 3 times 60, 180. This is what I did now. Then for the second row, 3 times 24, you have 72. 3 times 3, you have 9. 3 times 0, you have 0. Okay? 3 times minus 54, you have minus 162. 3 times 6, you have 18. 3 times 69, 207. So this is matrix 3P cubed. Because matrix P is 3 by 3, you write 3 by 3 identity matrix, the one in F of P. So this is F of P now. This matrix is 3P cubed. 3P cubed. This is matrix P, and this is a corresponding identity 3 by 3 matrix. So when we are adding and subtracting, what happen there? No, the order is the same, 3 by 3 all through. So you have minus 27 minus 2 plus 1. That is what you have here. Now let me jump to the element in the first row, third column. That is minus 62. What you have here, followed by this minus what you have here. This is minus now, then minus 2. See that? You take care when dealing with minus. Then this plus follows, and the entry 0. When you do all of that, you add minus 22, okay, minus 27 minus 27 minus 2 plus 1. Okay, so the next thing is to add minus 27 minus 2 plus 1, that is minus 28. So you add this, 36 minus 1 plus 0 is 35. You have 180 minus 2 plus 0, that is 178. The second row, 72 minus 3 plus 0, you have 69. Then here first, minus times minus is plus, so you have 9 plus 1 plus 1, that is 11. You come here, minus is plus, so you have 0 plus 2 plus 0, that is 2. That is 2. Then when you come here, minus here is plus, so you have minus 162 plus 2 plus 0, that is minus 160. Then you have 18 minus 1 plus 0, that is 17. 207 minus 5 is 202 plus 1, you have 203. So this is how we find polynomial of a matrix. It involves multiplication. After that, you can also do scalar multiplication. Then you either add or subtract, depending on the signs that connect or joins the various parts together. All right. End of lesson 6. Thanks for watching and learning with Petakus Education Community. Don't forget, watch out for more from the voice of Petakus. For questions and inquiries, use the comment section. We attend to them. For the complete package of this topic, lesson 1 to 11, for offline usage, you can contact the voice of Petakus via this WhatsApp number or through the email address. At a very little token, the complete package will be delivered to you. Lastly, if you are not saved, your life will be in crisis. Katakata everywhere. To avoid that, give your life to the one that can save you. That is the Lord Jesus Christ, and confess him as your Lord and personal Savior every day of your life. If you are saved already, I tell you, big congratulations. Live righteously and be prepared. Take good care of yourself. Stay out of trouble. Stay well. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely, and the Lord will bless you. The voice of Petakus says goodbye for now.